Think about this for a second. In 1937, this one element killed 36 people in less than a minute. Today, it powers cars, and the only thing that comes out of the exhaust is water. And right now, deep inside the sun, it's creating enough energy every single second to power all of human civilization for 500,000 years. We're talking about the exact same atom.
All right, let's get right into it. We're talking about hydrogen, element number 1. And by the time we're done here, you're going to understand why it's at the very center of this massive energy debate, and why some of the smartest people on the planet think it could make fossil fuels look like, well, Stone Age technology.
So, what is this stuff? It is literally the simplest thing in the entire universe. You've got one proton in the middle and one little electron zipping around it. That's it. That's the whole thing. And that incredible simplicity, that's the key to its unbelievable power. But to really get a handle on its promise, we first have to understand its danger.
Yeah, hydrogen has it's got a dark side. The same thing that makes it so full of energy, its energy density, is also what makes it incredibly destructive, a lesson we had to learn in some of the most dramatic ways you can imagine.
Let's rewind to May 6, 1937. Picture the Hindenburg, this absolutely colossal airship floating towards its dock in New Jersey. It's packed with 7 million cubic feet of hydrogen gas. And then something goes horribly wrong. A spark hits the gas, and in just 34 seconds, the entire thing is gone. It's a terrifying, perfect example of what happens when hydrogen meets oxygen. It doesn't just burn, it explodes.
But an accident, that's one thing. Intentionally weaponizing that power? That's a whole other level. Because hydrogen doesn't just make airships fall out of the sky, it's the fuel for thermonuclear weapons.
Okay, to really get our heads around the scale here, let's set a baseline. Think about the power of the atomic bombs from 1945. Let's just call that 1 unit of destructive force, okay? 1x.
Now, what happens when you bring hydrogen into the equation? A hydrogen bomb isn't just a little bigger. We're talking 3,000 times more powerful. It's an almost unimaginable leap in power. It's just a completely different league.
I mean, get this. The largest H-bomb ever tested, the Tsar Bomba, created a mushroom cloud 40 miles high. Its shockwave was so powerful, it literally circled the entire planet 3 times. And all of that destructive force came from fusing the simplest little atom in the universe. So you see, hydrogen itself isn't good or evil, right? It's just raw power. What matters is what we decide to do with it.
So we've seen how hydrogen's power can destroy. But what about the other side of the coin? Because that exact same power, it can also create. And not just small things. On a cosmic scale, it literally created, well, pretty much everything.
Now, hydrogen isn't just one thing. Think of it like it has 3 main flavors, or what scientists call isotopes. You've got your standard hydrogen, protium, then there's deuterium, or heavy hydrogen, because it's got an extra neutron. And finally, you have tritium, with 2 neutrons. And these last two, deuterium and tritium, they are the absolute superstars when we start talking about fusion power.
And this chart, wow, this really puts it all into perspective. By mass, 75% of all the regular matter in the entire universe is hydrogen. It's the original stuff, the fundamental building block from right after the Big Bang.
So how does it build things? Well, inside stars, it's like a cosmic pressure cooker. The heat and the pressure are so immense that hydrogen atoms literally get slammed together, fusing to become helium. And when that happens, a tiny bit of their mass vanishes and gets converted into a massive amount of energy. That's E equals mc squared. That is what makes the sun shine.
And this is where it gets really mind-blowing and personal. In bigger stars, that whole fusion process keeps going, creating carbon, oxygen, iron, all the heavier stuff. And when those stars die in a massive explosion, they blast those elements across the universe. So what does that mean? It means every single atom in your body, the carbon in your cells, the iron in your blood, all of it was cooked up in the heart of a star that started out as just a giant ball of hydrogen. You are, quite literally, made of star stuff. Okay, so that's the cosmic scale. Super cool. But let's bring it back down to Earth. How can we use all this incredible power to fix our very real energy problems right here, right now?
Well, a big part of the answer is a device called a fuel cell. And it's a remarkably clean process. Hydrogen gas goes in one side. It gets split apart, the electrons run through a circuit to create electricity for a motor, and then it all recombines with oxygen from the air. And the best part?
The only thing that comes out the other end is pure water. That's it.
Okay, but this is where things get a little heated. You got people like Elon Musk, who famously called hydrogen fuel cells mind-bogglingly stupid. He argues it's just way more efficient to use electricity directly in a battery. And you know what? For passenger cars, he's got a pretty strong argument. But that's kind of missing the bigger picture, because hydrogen is perfect for the heavy-duty stuff that batteries just can't handle yet, like long-haul trucking, giant cargo ships, and airplanes.
But here's the catch, and it's a big one. It really matters how you make the hydrogen. Most of it today is gray hydrogen. It's made from natural gas, and that process releases a lot of CO2. Blue is better. You still use natural gas, but you capture the CO2. But the holy grail, the real goal, is green hydrogen. That's where you use renewable energy, like solar or wind, to split water into hydrogen and oxygen. Absolutely zero carbon emissions.
And believe me, this isn't some far-off pipe dream. The world is putting serious money on the table. The European Union has committed nearly €500 billion. Saudi Arabia is building a massive $5 billion green hydrogen plant. The hydrogen economy? It's not coming, it's already happening.
But hold on. Using hydrogen as a chemical fuel in a car, that's just one piece of the puzzle. The real grand prize, the ultimate goal, is to harness its nuclear power, to literally build a star right here on Earth.
So, the nuclear power plants we have today, they use something called fission, where they split heavy atoms like uranium. It works, but it leaves behind some pretty nasty, long-lasting radioactive waste. Fusion is the complete opposite. You take light atoms, like hydrogen, and fuse them together, just like the sun does. The fuel is everywhere, and there's almost no long-term waste. It's the holy grail of clean energy, no question.
For decades, this was just a dream. But after 70 years of research, scientists at the National Ignition Facility in California did it. On December 5, 2022, they achieved ignition. For the very first time in history, a controlled fusion reaction generated more energy than was put in to get it started.
And this wasn't just a small step. This was huge. It was front-page news all over the world. The U.S. Secretary of Energy called it a historic milestone, one of the most impressive scientific achievements of this century. It was the proof. It proved the physics works. Net energy fusion is actually possible.
So what does this really mean for us, for the future? Well, the fuel for this, that deuterium isotope we talked about, you can get it from ordinary seawater. And the Earth's oceans hold enough of it to power our entire civilization for quite literally billions of years. Just let that sink in for a moment. A virtually endless supply of clean energy. So, there you have it. The simplest atom in the universe, an element that can destroy cities or build entire worlds. We have finally proven that we can harness the very same power that lights up the stars. The technology is here, and it is moving fast. The only real question left is, what do we choose to do with it?